Let's begin part B of section 2.1 where I left off. We were talking about dependent solutions. And this meant that we have all kinds of possibilities that are driven by the last variable given. And we can see that this first example, we definitely have a dependent system. We have variables x, y, and z, and only two equations. So already we know there has to be a dependency on z. Right. So now that we have that, let's look at what we do using our echelon method. Well, the first thing I want to do is transformation, and I want to interchange the structure. So I'm going to have 4x plus 7y plus z equals 4, and 3x plus 5y minus z equals 1. So what I'm going to do is take row 1 and subtract row 2 to get the new row 1. All right, so that's the math I'm going to do. So I'm going to have 4x plus the 7y plus z equal 4, and then I'm put a negative through the next one. Negative 3x negative 5y plus z equals negative 1. When I do this math, I'm going to get x plus 2y plus 2z equals 3. All right, so now this is my new row 1. Okay, so I'm going to write that down. X plus 2y plus 2z equals a 3. All right, notice that the negative goes all the way through. Okay, and I better put that out there. Negative 1. All the way through, changes all of the signs. And then I'm going to write the second one because I haven't done anything to it yet to change its structure. Now remember, what we're trying to do is get one variable x on one line and one variable y on the next line, and then refer everything to z. So now I'm going to take, let's see what I'm going to do on the next one. I'm going to say R2 minus 3 R1s to equal the new row 2. Okay, so this means I'm going to start with row 2, 3x plus the 5y minus z equals 1. And now I'm going to multiply this guy by a negative 3. And that gives me a negative 3x, a negative 6y, a negative 6z, and a negative 9. All right. This zeroes out. That's good. I'm going to have a negative y minus 7z equals a negative 8. All right. Now, I'm going to multiply this guy by a negative 1. And now I end up with y plus 7z equals 8. And I'm going to write that down. So now what I have is, remember I started with x plus 2y plus 2z equals 3. And now I have this, y plus 7z equals 8. So now I'm going to identify y in terms of z. And that means I'm going to solve for y. All right. Okay. So let's do that next. So again, I'm going to take this part right here and solve for y. So y plus 7z equals 8. I'm going to subtract 7z from both sides. And that gives me y equals 8 minus 7z. Does everybody see that? Okay, because this becomes an identity. Right. Okay. So now it's a matter of figuring out, because that is a solution. This part is a solution. So I'm going to do x in terms of z by substituting y. All right. So I'm going to substitute that entry for y in the x line, the first one, row 1. X plus 2 parenthesis 8 minus 7z plus 2z equal 3. Okay, I'm going to do distributive property. X plus 16 minus 14z plus 2z equals 3. I'm going to combine like terms. In other words, these guys right here. So I have x plus 16, and this is minus 12z equals 3. I'm going to subtract the 16, and that gives me x minus 12z equals a negative 13. Okay, so far so good. Okay, so I have that. Now I'm going to add the 12z. Well, I can't do it to 13, so now I have x equals, I can say it as a 12z minus 13. All right, so now my solution, my dependent solution is, all right, for x, now remember I'm going to have x, y, and z, and everything's a dependent. So I'm going to have, for x, I'm going to have 12z minus 13. For y, I'm going to have 8 minus 7z. And my independent variable is z. And this is my dependent solution. Should enter in the computer. Is everybody comfortable with that? Now remember, these are not hard, but they're labor intensive. And so you must leave room and paper to write all of your steps down and do proper math. Here we go. We have another one, of course. Again, we're going to have a dependent solution. Because we have x, y, z variables, and only 2 equations. So there's no way we could get 3 of them with that few of system of equations. So here we go. All right. So the first one looks good. So we're going to keep the first one because I have 1x. So what I want to do is, of course, do 2 times row 1 minus row 2 to give me a new row 2. All right. So I'm going to have this guy times 2. So I'm going to multiply by 2. That's a 2x. That, oops, and I put 24, didn't I? I meant x. I said x. Just plus 8y plus 10z's equal 40. And I'm going to subtract the second row, minus the 2x, minus 2x, plus the y, minus the z, -4. All right. So this zeros, and now I have 9y plus 9z equals 36. I'm going to divide by 9, 9. So that gives me y plus z equals 4. Well, in this case, I now can do what y is in terms of z. So I have this now, x plus 4y plus 5z equals 20, and I have the new y plus z equals 4. So I'm going to do an identity. Terms of z. So as I do that guy, I'm going to have y plus z equal to 4. Then y must equal 4 minus z. All right. So this is my identity. So I'm going to have my x plus 4 times this guy right there, right? I'm going to do distributive property. Find like terms. 2. Subtract the 16. I'm going to subtract the z. And I have the same thing. So for the x. So my dependent solution is for my x, 4 minus z. For my y, 4 minus z, and z as my independent variable. Okay. All right, we have one more. And on this one, we want to find solutions. Okay, well, we know that these are products or whatever they can be. We know that Z has to be greater than or equal to 0. So must all of the terms. And Z is the driver for how many solutions we can have. So the first step to finding how many solutions we have is to find the dependent solution to the system. And of course, this one's easy because we already have an identity. Y minus 2Z equals 20. So Y equals 2Z plus 20 is our identity. Terms of Z. So now what we're going to do is substitute. So on the row 1, I have 2x plus 2 times y, which is 2z plus 20, plus 4z equals 70. All right. Now, I should have divided by 2, but we can do the math. 2x plus 4z plus 40 plus 4z equals 70. All right, I'm going to combine like terms. 2x plus 8z plus 40 equals 70. All right, I'm going to subtract 40 from both sides. So I'm going to get a 2x plus 8z 30. All right. And now I'm going to subtract 8z. 2x equals 30 minus 8z. So this is a solution, and this is a solution in terms of z after I divide by 2. Sorry about that. 15 minus 4z. Sorry. We don't want 2 of anything. We want 1 of anything. So now we have it, and we're going to figure out what we have as to solutions. So we're going to set each dependent expression to greater than or equal to 0. So, okay, for x equals 15 minus 4z, we know that the z has to be a greater than or equal to 0. So we're going to say 15 minus 4z has to be greater than or equal to 0. All right, so I'm going to subtract 15, and I'm going to show all of these steps in case we're rusty about inequalities. That leaves me a negative 4z is greater than or equal to a negative 15. Okay, now that's all good and well. Now we're going to divide. When we divide, when an inequality equation is divided by a negative, then the inequality flips, I should say, flips. All right, so if I divide by 4z, by negative 4, sorry, then I'm going to have z is less than or equal to a positive 15 force. And a positive 15 force is 3 and 7,500, 3.75. So z has to be less than that value in order to work for both of the linear equations. Now we're going to do the y. Y equals 2z plus 20. So we're going to say 2z plus 20 has to be greater than or equal to 0. We're going to subtract the 20 and divide by 2. Well, we said they can't be negative, right? So I've got z is less than negative 10. So we know then that only solution for z greater than or equal to 0 is 0 to 3, because it has to be a whole number. Well, that means we have 4 solutions. Oops, if I could spell. The 4 solutions are the set of 0, 1, 2, and 3. That's where the 4 comes from, because it's inclusive of 0, and 0 is one of the solutions possible. All right. Excellent, class. You did super. All right, I'm going to stop right there and let you absorb what we've done. And now we're going to venture into language problems or word problems. So I'll see you in a minute.